Well, hello and welcome to the Unofficial Unreal Engine podcast, where we talk about all things Unreal Engine and also AWS credit traps. We're your hosts. My name's Alex.
And I'm Jacob. Welcome to another fantastic episode inside of the Light Twist Studio for those who are on YouTube. For those who are not, you can still you can rate it, you can subscribe. Thanks for all our loyal listeners. And we got a special guest with us once again in the studio, none other than Vikas. Do you want to reintroduce yourself?
Yeah, absolutely. Really great to be here. I'm Vikas Reddy. I'm co-founder and CEO of Light Twist. We build a software that lets you stream into a virtual studio like this one with just an iPhone and webcam. So, excited to host you guys in the studio here today.
Yeah, we're excited to be back. And also, just for anyone who's watching on YouTube and sees the beautiful visuals we have here, can we get something up on the screen share?
Yeah, absolutely. Let's do it. I'll share this up here.
It's a very cool environment. So we were thinking that today, we're kind of toward the end of summer. This is technically season 2. Things are a little bit strange with our timing because, you'd think season 2 would be starting properly in September, but we're just having a grand old time wrapping up our summer with our second episode of season 2. And I thought it would be kind of fun for us to go off the beaten path a little bit about all the wonderful things we have to say about Unreal Engine and talk a little bit in this episode about, not necessarily just frustrations or things that are giving us headaches, but just general challenges. I talk to a lot of developers who say oh, Alex, you make it all look so easy. How do you do it? And I think it's important for everyone to know just how many hurdles all of us have to jump through to be able to get any kind of cutting edge software, not just Unreal, do the things we want. So we thought Vikas would be an excellent guest to have as we just kind of talk a little bit about pipelines, hurdles, overcoming adversity, things like that. So Jacob, Vikas, how's that sound?
Well, if anything breaks in the studio today, we'll have something to talk about.
That's
true.
We can troubleshoot it in real time.
That is true.
Well, I think that's a great idea. There's always a dark side to all development, and certainly Unreal. Yeah, Unreal never crashes. I don't know if you've heard.
Never, not even once.
Not a single time.
Man. Oh, I'll start off with because I want us to give tips while we're chatting here too. When you install Unreal Engine in the Epic Games Launcher, make sure you hit a little checkbox, which is going to quadruple the size of your Unreal Engine installation, but it's something like install with engine source or something like that. And what that's going to do is make it so that when Unreal Engine crashes, it's going to give way more information about what caused the crash. And then if you, Google that or ask ChatGPT or share it in forums, it's going to be much, much easier to get to the root of what is causing a crash. So there we go. We'll start right off with a tip for dealing with the inevitable crashes that happen.
What are your favorite crashes, Alex? No, I mean, a lot of the stuff that we've talked about in previous episodes, particularly with the kind of stuff that you do, Alex, in AR VR, is always you tend to do a lot with broken features. Give us the highlight reel of what sort of things are still broken in the AR VR platforms in Unreal. What's been the most frustrating issues to work with in the past few versions or since 5.0?
Yeah, I mean, it's tricky because I'm the kind of person who falls in love so quickly with the bleeding edge of what's possible and that potential. And I remember the first time I saw the video of Echo in the Land of Nanite, or whatever it was called, Lumen in the Land of Nanite, and thinking about the possibilities that all that represented, in particular for VR, which often struggles so much with maintaining frame rate and, dealing with draw calls. And that was such a hurdle for me beginning as a developer in this world because I didn't train in game development or anything like that. I was an architect. I understood how to make multi-billion polygon models, and that was all fantastic. But to optimize them and get them to run well in a platform like Unreal Engine was very much a challenge. So the possibility of having fewer technical hurdles in the way and the idea that people could just be more creative was very exciting to me. But that being said, Lumen, Nanite, a few other features, virtual shadow maps, things like chaos physics have been a little bit slower to stabilize and particularly become useful in things like VR than I'd like. So I'm the kind of person who keeps trying to tell people like, hey, this is almost ready, almost stable, please test it out, please, certainly when you have crashes, like share that with Epic Games, because they do read those crash reports and it is helpful. But I always feel bad when I tell someone like something is ready for prime time or it seems stable, and then they come back and say like, actually no, it's completely not, and we need to go back and stay in something like Unreal Engine 4.27. I do think 5.3 is a really major step in a lot of these directions now that we have instant stereo working in a pretty robust way. I'm still getting crashes, and we're still in a preview release of 5.3, but it feels very promising for just being able to hit better frame rates and start to use things like Lumen and Nanite in a really meaningful way in the crazy world of VR, where you're trying to hit 90 frames a second, a left eye, a right eye, maybe a third view if you have a spectator camera. And I've got a pretty cool demo that I plan on just kind of releasing to the public that hopefully becomes a nice showcase of all these features doing their best. And if everyone says, oh, it just crashed when I opened it, well, that'll be educational too.
Yeah, that's true. I want to pass this over to Vikas now. So, you give us some background on how long you've been developing the platform we're currently using,
Yeah.
and maybe jump into what's been the biggest hurdles in dealing with Unreal, and like
Yeah, I mean,
what's the latest.
we've had a yeah, it's been a bit of a journey since we started off. It's We started off actually more as a iPhone app, so we were kind of exploring this whole, hey, let's try to like make the something like what they did with the Mandalorian possible on the iPhone. And so we were exploring this whole space of like having a tracked camera on the iPhone, and kind of we actually created this whole workflow initially where we had a local rendering on the iOS device using I guess we were using Scene Kit, I suppose, or Reality Kit, but with like sort of so we had this initial challenge of like taking Unreal Engine environments and being like, how do we make this run on an iPhone? Like, how do we crunch it down? So we had a little bit of that. And then we had this whole thing of like translating AR kit poses into Unreal in the right way. So that was some of the initial stuff. But yeah, we even, with the, I'd say about a year ago, we leaned into this idea of like, let's build this, let's focus on like delivering this like virtual studio for people, YouTube creators, like people that are even creating like TV shows and different experiences. And I'd say some of the challenges, actually one of the biggest ones has been, what is the best way to bring real-time audio and video into Unreal and like replay it in a way that is performant, like works well and has like good audio visual sync. And honestly, I wouldn't even say we've like 100% solved that yet, but we ended up, we tried all of the different, there was a couple different sort of NDI based plugins that we started out with that we were testing out. But interestingly, one little quirk that we discovered is that a lot of the NDI stuff is it has this strong assumption that you're feeding video in locally, so like on a local network.
Yeah.
And so for people that aren't familiar, NDI is kind of this it's this video transport protocol. It's like a lossless format. Does like audio, video, and they have like other sort of metadata you can do. And it's often used in like virtual production sets and other contexts where typically you have a lot of stuff locally, and so you have like very low latency, like no like network issues. In our case, since we're trying to bring multiple people like we're doing here into the same environment, it was really it just ended up not being a good fit. No knock on the developers of NDI. It's just that they never built it for this type of purpose, and so we ended up having to build our own plugin in Unreal to receive audio and video data, and getting it all to sync and work properly was definitely a challenge there. And one of the things that was a pretty big pain that we've like kind of figured out some strategy around is, as you guys have probably seen too, is like building plugins for Unreal. The iteration cycles when you're doing development are super, super painful sometimes, because you've got to run the whole engine. You've got to you're kind of testing all this stuff. And then in development, there's like cases where just things crash randomly. It's almost different than when you're like running the engine in production. It's like much more stable, but in the development workflow, it can be a pain. And so like we ended up Gustavo, my co-founder, actually just recently did a pretty cool change, which is to kind of actually we've done this in a couple cases where we, instead of just trying to build everything within the Unreal context, we actually did it via DLLs. Um,
Mhm.
and this might be something that's pretty common knowledge with people that are like, hardcore Unreal developers, but for us, where we're just learning, it was a good strategy to speed up those iteration cycles. So we could basically build a plugin where it had a bunch of headers, a bunch of functionality, and then it would we could actually test it completely outside of Unreal Engine and as almost like unit test it, and then bring it back into Unreal, like and ship it sort of part of that workflow. So that's like one of I'll think of some more, but that's probably one of like 10,000 random things that we figured out and effed up over time.
So where did you end up with like the protocol you're using for transport now? Did you ditch NDI and presumably you had to, but
Well,
how are you
so
streaming things today?
yeah, we actually so the way we've done it is we actually ended up doing something where we have we're still using NDI, but we ended up building our own custom essentially player within Unreal. So it's actually like because we found it to be convenient to so right now we offload the computer vision processing. So like the segmentation or green screen that's running on all three of us right now. I guess in your case, Jacob, just sort of automatic segmentation, no green screen. Me and Alex are rocking
Mhm.
a like kind of crappy green screen here. And then what we're doing is we're processing that first on a totally separate machine, and then transporting it in within an internal network via NDI to our render servers, which are running Windows, running on Unreal Engine, have a nicer GPU for rendering. So we used it internally, but we had to do a bunch of work to get the audio and video to play in sync on the server side
Gotcha.
when it was received over this like over the network essentially, which was really interesting. It was one of the weird things that we found out too is that even just the built-in sort of NDI player from I forget it's called like Intertech. I forget the company name for NDI, but that they built was like it. If you try to play stuff over like a remote network where there's like maybe different network conditions, it even the test player doesn't play stuff in sync for audio and video. So we couldn't even use that to like test, which was super challenging. Um, but yeah, that was like one of the many things that we had to tackle there.
Yeah. So what about
Is the
from the?
company
Oh, sorry.
sorry, is the company New Tech? Is that
New
right?
tech, that's right, that's right,
New Tech, yeah. Great.
exactly.
Go
Yep.
ahead, Jacob.
I was going to ask. So from the browser up to cloud, what is that then?
Yeah, so there we're using it's basically using WebRTC. So
Okay.
we're using like there's an open source framework called LiveKit that lets you essentially it's kind of a nicer interface on top of just the core like WebRTC essentially, which is maintained by Google, and that's essentially letting our video stream, our video streams stream up to our server side. So
Right.
and then on our server we're pulling those feeds and then processing them, um, and then yeah, that's part of that framework too. And in fact, there we actually started out with something more where we were just streaming directly to our computer vision servers via TCP. But that when you don't have great network, that causes a whole bunch of issues. It's like it's lossless. It just like backs up over time, and so um, that change was like a relatively significant one. But that was separate from Unreal Engine itself, I suppose. But it required a lot of under the hood changes. Um, and then the other, another just thing that comes to mind with Unreal is like we've had a lot of discoveries in like the a lot of the sort of built-in or even the assets on the asset store. They're not made to be compatible with. Essentially, they're not really they were never really made initially to be compatible with like Lumen and Nanite and
Right.
Lumen especially. And so we ended up having to go in and kind of tweak the materials, tweak the lighting a bit. Honestly, not as hard as as some aspects of it was not as hard, but we're also starting to like poke into like using some of the materials in the material library from Quixel as well to try to like make the materials a little bit better. But yeah, it's a bit of a challenge sometimes to try to get it to look a little bit more realistic in in Unreal for sure.
So would something like this studio be an example of that? Or yeah, how did this look out of the box versus the modifications you had to make to it?
Yeah, like a lot of it was like undoing some of the hacks that were put into the studio initially by who built whoever built this for like Unreal 4.27 likely. And um, when you import it into Unreal, there's a bunch of like on the the post process volume, there's a bunch of like direct exposure controls or kind of like bracketing. So there's like an auto exposure and stuff, and it was likely super useful on Unreal 4 427, but with like the nice like global illumination with Lumen, it actually kind of like made it way too dark. It was like a weird setup essentially. In fact, if you compare this to our previous episode, you'll see a difference because I just tweaked that. I like undid that change, or I undid that sort of hack in there. And so there's some stuff like that, but there's still some stuff that I think there's some materials and different things that we're just trying to figure out. And I'd say that's in general one of the tricky things with Unreal that you guys are probably seeing too is like there's so many different knobs to try. It's almost like this crazy parameter space of like you have to kind of learn what, at least for myself, who's a relative novice, I had to spend a bunch of time like learning what knobs to even try, um, to even like try to be like, okay, here's all the things. Um, and that's yeah, there's a bunch of stuff in like what type of anti-aliasing should you use, like what are
Yeah.
the different render settings you have access to. Um, but yeah, I don't know if you guys have seen that too, but that's one of the biggest like learning curves I've had is like knowing what I don't know.
Yeah. Yeah, I see people in particular when it comes to using third-party plugins. A good example being something like NVIDIA DLSS, not knowing what things they need to adjust in the default Unreal Engine settings to really use that in a meaningful way. For example, temporal super resolution kind of competes with some of the things that DLSS does, so it's important to know how to set that up correctly. Similarly, Vikas, I'm curious what plugins you're using out of the box with Unreal versus things that you have to develop on your own. So like based on what you're saying, I could imagine, WebRTC, maybe you're using the pixel streaming plugin, maybe you're using the remote control plugin, maybe with your earlier development, the virtual camera plugin might have been
Mhm.
important there. I'm curious if any of that ends up being useful or if it's something where you like start with it and then you turn it off and you develop something more on your own. Because people
Yeah,
ask me all the time, like, where are there like templates and good starting points in Unreal Engine and then in the marketplace, and in which places do you really just have to like blaze your own
just do
trail?
it.
Yeah.
Yeah, on the plugin side, like yeah, we there's a couple that like some of the ones that are built into Unreal were actually super useful for us initially. So we have like we use the remote control API initially to kind of like instrument the studio. So in a lot of ways, it was really useful to kind of get up and running because we got an initial version of like this cloud version of Lightwist up and running. And when I say we, I mean it was mostly Gustavo, my co-founder. Got it up and running in like about a month, like an initial very hacked up version, and a lot of the built-in stuff was super useful to just kind of get it up and running and working. And then we did actually end up swapping out most of the plugins. The remote control plugin we actually swapped out for we built our own sort of reflection API, sort of a lower
Huh.
level like socket thing that we might even consider open sourcing, or maybe we'll apply for an Unreal Engine Epic Mega Grant or something for. But there's a little because we found that the remote control API it was relatively painful to do certain things via that API. And then we ended up we used OWL, like the Off-World Live plugin for streaming out via NDI, but then we ended up swapping that out for our own just our own thing that just grabs the video feed and outputs it because we were just using a small part of the overall like Off-World Live functionality. Um, and then yeah, we are still using the uh, live. Sorry, I think I forget. I'm blanking on the name of it. The thing that lets you uh, see it. live stream essentially.
Live link,
Live link, or not? No, not live link. It's
literally
the
for streaming.
yeah, for streaming. It's called
Pixel
wow,
streaming or
pixel streaming. Yeah, yeah.
yeah,
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 right,
exactly.
yeah, that
Uh,
one.
exactly. So we're using it now, but we found like that. So that's been so the sort of preview. Maybe I'll do a little screen recording so some people watching the podcast can see this too. But essentially, the pixel streaming is what we're using to kind of power the preview in Lightwist, where you can see kind of a preview of like what the recording is going to look like. But we might end up swapping that out for just using with the existing WebRTC like session we have already. So because we found some
Mhm.
issues there at as we like where it kind of stutters or has some random issues here and there. But yeah, overall, like I'd say like the plugin ecosystem was awesome to get started, but like yeah, it's pretty. At least in our specific case, we ended up swapping almost all of the plugins we were based on, just to
Hmm.
kind of get our own customized functionality.
And what version of Unreal Engine is this all running in right now?
So we got it on. It's on Unreal 5.2.
Okay,
Well,
great.
5.2.1, I guess specifically.
One, yeah.
Yep. Yeah, yeah. But yeah, I think we'll probably, we kind of have it set up now where it's relatively easy to, if Unreal comes out with a new 5, when they ship 5.3 to production, we should be able to upgrade to that relatively easily. But that's actually one big advantage, I would say, to not relying on too many plugins is like when you are relying on a bunch of plugins, you're kind of bound by the lowest common denominator of like whatever plugin version you're based on. So you're like, well, I would love to upgrade, but like Off-World Live hasn't upgraded to 5.3 yet, or the Remote Control API doesn't support 5.3. So I think I think there's this kind of plugin hell that I'm sure people get into in terms of like trying to upgrade.
Yeah,
I
and for go ahead,
sorry,
Jacob.
go ahead. No. You first.
I was just going to say that even for people who are not talented C++ developers who are going like very low level with everything in Unreal Engine source code, it is worth testing to see if a plugin that you particularly care about is going to upgrade in a relatively straightforward way. And there's basically two steps of that. One is literally just try dropping your, let's say, 5.2 plugin in 5.3 and see if it opens. It might give you a little warning that says, hey, this plugin says it was designed for 5.2. Do you want to try to open it anyway? And you say yes. That warning, by the way, can be turned off just by changing one line in the .u plugin file, which is something you can open up in like Notepad or Visual Studio or whatever. But then, even if it doesn't compile at that point, then the next step is basically just try opening it in a project that has C++. And the simplest thing to do is you can literally just start a new C++ project, like literally open up Unreal Engine 5.3 in this example, do a blank project, and there's an option there for Blueprint or C++. And I usually have a project in every engine version that I just call Plugin Upgrader. And it's literally just a place where I drop plugins that I want to see if they're going to cleanly upgrade. And sometimes they do. Like DLSS 5.2 right now, they just released DLS. This is going to sound so confusing. NVIDIA just released DLSS 3.5 for Unreal Engine 5.2. And yet, if you actually try to do just a simple, straightforward upgrade from 5.2 to 5.3 with that, it will work. Some of the other plugins won't do it, like Streamline, but if all you need is the kind of out-of-the-box vanilla DLSS, great, you can start using that in 5.3 right away and maybe get some of your frames back. But then the other thing you might find too, like I do not consider myself a C++ developer at all. Back when I was working in Unity a lot more, I got to know C# pretty well, but that's actually pretty different, I found, from C++. But if you try to compile your project and try to upgrade your plugin and it doesn't, it fails, in Visual Studio, it might actually give you an error that is maybe plain language enough that you actually can see like the exact line where you might need to go and change something.
Yeah.
I'd say that happens to me maybe 20% of the time where like I actually can edit the code in such a way where it's going to upgrade okay. And then there's of course people you can hire who are going to do a much better job at this.
Yeah.
What does that process look like for you, Vikas?
Like I mean, right now, like that's yeah. Like I was gonna say, like in that case where you do hit those compile errors, even if it's a little bit advanced, I would highly recommend like using ChatGPT to like
Sure.
just like plug it in and be like, how would I fix this error? Because honestly, there's been a couple cases where I've done that myself, where it's like, okay, I don't want to like incur like looking at a bunch of documentation on this. Let me just like paste this into ChatGPT, and especially for stuff where it's like relatively esoteric, like language specific stuff. I've done that with Rust and other languages, C++ too. But yeah, like in the Lightwist case, where yeah, we a lot of our code is in C++, or like the parts that interact with Unreal Engine are in C++, and then some of our DLLs are actually built in. Um, uh, well, I guess yeah, I guess our DLLs also are built in C++, the ones that work with Unreal, but the rest of our backend is mostly written in Rust. So it's we have enough like programming ability to kind of just like like go in there and kind of edit the things that we need to do to kind of upgrade to the latest engine for our own plugin. Um,
Mhm.
but yeah, we still hit the I think at least historically, until we started swapping out some of these plugins for our own code, we were still hitting these limitations. And I would say like there's definitely a lot of stuff like it's been helpful uh, to basically be able to tap into the knowledge of people on the team that have more deep Unreal Engine specific knowledge.
Yeah.
And so that's because there's a lot of stuff that's not really, it's not like a general programming thing. So it's like, even though I would consider myself a generally good software engineer, there's a lot of Unreal Engine specific knowledge, and so I think it's actually an interesting opportunity. And like for people that understand Unreal really well and can do a bit of coding, or even like you said, just fix up some minor stuff, you can do some stuff that like a lot of people in the world can't do because they don't have that deep knowledge, and or the or the wherewithal to like deal with all the Unreal Engine quirks. So, and I actually had a question for you guys. Like, again, this is coming from a relative novice, but I find that some stuff in the Unreal Engine editor is super easy, it just works. But some stuff is just like a effing nightmare. Like I just like I'm just like it makes me feel like doing some things that seem like they should be basic. I'm just like I am a f like I'm an idiot. Like I
Yeah.
forget. Are we allowed to swear on this podcast?
You can, but then we just have to mark the podcast as explicit.
Oh yeah, yeah. Okay, okay,
Yeah,
okay.
I've sworn on every episode. So
Okay, 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 great. I was gonna say like yeah, there's so many parts of Unreal Engine Editor that make me feel like a fucking idiot. Where I'm just like,
Yeah.
I swear to God, this worked yesterday. Why won't you fucking work?
Hmm.
Especially around like movie render queue, or
Yep.
like I'm having this thing now where I'm trying to render. I like did this like I've been testing out audio to face with like a MetaHuman, and it looks really
Excellent.
cool in the editor, and it looks awesome when it in the preview for the render thing, but when it outputs for some freaking reason it's out of focus, or and then it took me forever to actually like figure out like how do I change the parameters on this? How do I like
Was it
change the render
real
settings?
quick
Yeah,
on that? Because
yeah,
in the past, when I've seen that error, for
yeah.
a lot of people, it ends up being if they're not in like a cinematic mode, if they're in like medium or even high, sometimes you don't get depth of field, so you don't see the actual like out of focus problems until it's exported. But yeah, go ahead.
Yeah, yeah, that could be. Yeah, that actually could be exactly it. That might be. Maybe I should go back and check that right now. But I swear I had it selected in the editor as like cinematic mode, and then yeah, it's like this is the kind of stuff where you're like, well, now did I or did I not? Because some of the stuff is so intricate where you're like, you got to remember to do X, Y, and Z. And if you're subtly off by like one thing, it's like your whole thing is like fucked.
Yeah,
So yeah,
there's so much of
I,
that.
I get the feeling that it's like with the Unreal Editor just has a ton of surface area and it keeps growing.
yeah,
But I mean I remember when I was doing just a lot in blueprints, like there are always so many different ways for that to go wrong, I remember when they were first really kind of bulking up sequencer, for example, and like being able to like create a blueprint where you're accepting each frame or keyframe in sequencer as an event, and then you're trying to like update objects with values off of the timelines, and there were like three different checkboxes you had to hit in the right place. I don't even remember at this point, but
yeah.
there were like checkboxes all over the place that you had to hit to make that work properly. Otherwise, it would just spaz out or do something completely random where it'd be like, all right, I'll animate that first frame and then the rest I'm going to do nothing. And I'm sure Alex at this point is laughing to himself like, oh, I know that checkbox. But like, yeah, I understand the same frustration, especially if you don't spend as much time in the editor.
Yeah.
Like, from my perspective, I don't get to spend a whole lot of time inside of Unreal these days, which is always upsetting to me. Because when I do get a chance to jump in, it's this exact stuff that upsets me, where it's like, oh man, I wanted to just try out this new feature, and I got stuck on this like one little implementation, detail that I couldn't quite just look past, and so I totally get that frustration. I did want to mention something real quick actually about what you were saying before with plugins, though. Just as a general comment on Unreal's plugin ecosystem, like this is one of the places that Unity has historically done a lot better because of the C# interface, right?
Yeah.
Because that's a nice middle ground for a lot of developers, and obviously not to comment on the quality or the scripting ability of C# or like that whole ecosystem, because I hate .NET and everything around it, but like C# itself is just a lot more accessible than C++ for most folks, and being able to work with that in a virtualized runtime where you don't have to compile the whole engine and you can develop quickly and all that, like that's super valuable. And that's been one of the big arguments for why Unreal needs a similar scripting system. Thinking about Python is in the editor, and Python you can do non-runtime things, so that's nice for when you're trying to just script things inside of working in the editor, or you're trying to create tools. But it's not the same thing as a plugin like a C# plugin in Unity. But maybe that's what we're going to get with what we're seeing in UEFN and what's it called? Verse, right? I think that's part of the concept, is that maybe at some point we do have a scripting language more like Verse that improves the overall usability and development environment around things like plugins and content plugins and stuff like that. The whole marketplace itself needs a big boost, and certainly that's something that we're going to see continue to mature, I'm sure, with everything come around about what they're doing with Megascans and their other acquisitions. Like, we're going to see, I think, a lot of improvement there. But yeah, my hope is that it would improve to the point where developing plugins is easier, and you're not either just doing blueprint plugins, which honestly most of the time suck. It doesn't give you, like, most of the time the only reason you would develop a plugin is having access to those lower level interfaces, or to do more runtime scripting. So like, I don't know, that's my take. But going back to what you were saying about the editor, yeah, I want to make sure we continue that conversation in this.
Yeah.
I find it very to work with Unreal.
I wonder if there's something. I wonder if like some point somebody's going to build like maybe Unreal themselves. Like I saw somebody for Blender. There's like a fork that's trying to build like a nicer UI, like a better UX, essentially, like built on the same code base, but sort of with different maybe UX goals. So they're going for like how do we simplify a lot of the like most common workflows, and
that's like Twinmotion, right? Like, I mean, Twinmotion is a view on Unreal Engine from the perspective of AEC, right? Like,
yeah.
And I think there's other industries you could do that for sure. But I'm not sure the solution is like a simpler editor, to be honest.
Yeah. That's fair. I guess in some sense, yeah, you probably end up building like higher level tools that are kind of like workflow specific rather than because I guess like to their credit, like it's probably like what they've done at least is that at least most stuff is accessible through the editor, even if it's a super pain in the ass to get to it or it's buggy. it's still there, and so you can do all that without doing any code really, especially with via blueprints. And so that's actually pretty nice. But yeah, I think that's what will end up happening is probably, I mean, in some ways that's what we're doing with Lightwist is we're kind of building not like exactly like the same type of UI, but it's like let's take the specific sort of very narrow subset of what Unreal Engine can do and kind of make a nicer UX around it and just make it, integrate it, like vertically integrate it with a bunch of stuff. And yeah, like you said, Twinmotion is a good example. And there's a bunch of other tools that are kind of like that. Like Xsymmetry is another one.
Yeah, I just think it needs to have some sort of focus on a vertical or use case, because otherwise I know exactly how that engineering project goes, where it's like, oh, I
Yeah.
could build a better Unreal editor, right?
Yeah.
And then you start just adding features like, oh shit, I got to build this, got to build
Yeah.
that. Where am I going to put this? And then you just end up with like
Yeah.
a different editor, but it has maybe a lot of the same
Yeah.
weaknesses.
Yeah, exactly.
Every time someone says there's too many standards for this thing, there should be one unifying standard. What happens is there's now, instead of 12 standards, there's 13 standards. Exactly,
Yeah,
just
exactly.
plus one increment.
Increment.
You guys got me thinking as well. I was talking to someone who's in Unity more these days than I am, of course, and they're saying, well, something I really like about the package manager in Unity, which is a lot like the plugins system in Unreal, is they're like most of the packages you'll find now that there's like a little sample button, and you can click the sample button and kind of open up almost like a little sample project that uses that package. And I thought, oh, that's really great. If only Unreal had that. And then I thought, you know what? Unreal does have a lot of that. Like in a lot of plugins, if you enable them, you can go in, and if there's a content folder in that plugin, there usually are some like blueprints or even a couple maps that are demonstrating how to use that plugin. And I feel like 99% of people never find those because, they're buried a little bit. And just by the fact that Unity is putting them a little bit more front and center, like you enabled this plugin, would you like to open the sample content for it, is kind of a nice UX move.
Yeah, I mean, whatever. Do they still maintain the sample content, like the big Unreal Engine like sample content?
Yeah, the
project?
content examples that's
Content.
still amazing. I pop into that at least once every month or two because they're constantly updating it with new things. So I was in there over the weekend looking at all the chaos physics examples because they do a great job keeping that updated.
Yeah,
Yeah, so they got some good stuff in here.
it must be huge now, right? Like I remember when it was just a few hallways on like animation, physics, blueprints. It was just like, that must be exploding right now.
Yeah, there's like 5 maps all dedicated to just different kinds of animation, and like here's retargeting, and here's like different kinds of mocap techniques, and there's a ton of stuff there. It's really, really great. So anyone who's trying to get acquainted with a new Unreal Engine feature, if you're like, oh, I've never really played with Niagara, I want to understand more about how Niagara works and how it's different from Cascade particles, like open up the Niagara hallway and just walk down it and read the little plaques and click on some of the interactable things, and it's a really nice visual way to get started learning these things, and then get out of runtime mode and like open up some of those blueprints and understand how some of those things are constructed. It's really helpful.
That's how I learned most of like what I know about things like Niagara in particular, because like you look at one of those systems and you can find lots of YouTube tutorials and stuff like that, but I always found it super useful to like go one step at a time in that hallway, try and replicate it by just opening up those particle systems, trying to replicate it myself and going to the next one. Like you would be amazed how proficient you can get in any tool in Unreal just by doing that.
I'm trying
100%.
I'm trying to see if there's a way to search the you can filter here too. I'm looking at the old one, but it is pretty nice. I could probably like look for the Niagara. I should probably do this. Is a good I can't spell Niagara apparently.
Niagara is I haven't touched it in a little bit, so I'm sure it's changed a bit, but it's really amazing, and they keep adding more and more for fluid simulation and for everything else. It's really pretty amazing what you can do inside Niagara. I think we saw a few new features on the 5.3.
Yeah. Mm-hmm.
Yeah, especially if there's like a good. I mean, I do think like the demo examples are like pretty key. Like that's definitely how I learned a bunch of stuff too. And also, I would say like one of the other things that's been super useful for getting over like weird Unreal Engine stuff is YouTube, obviously. Like YouTube,
Mm-hmm.
shout out to JS Films,
Oh yeah.
because like that's how
Yeah.
I learned like a bunch of stuff with Unreal. I was like, oh, how do I do like import a tracked camera into Unreal and like mess around? And it was like, you know, watch his YouTube videos. And he like, here, I'll pull up his page because it's
Yeah,
awesome.
Jay's great.
Yeah,
We
um,
actually keep looking for an excuse to get him on the podcast because he's
yeah,
a really wonderful teacher for everyone.
yeah. He's got an amazing channel, and I think, and obviously like unofficial. Actually, I just watched your video recently, Alex, for shout out to this exact podcast that we're on right now because about the mapping. It was like, oh yeah, I was doing the same thing with, or I was trying to map my AR kit to to the face, but then animate the body, and then I was trying to use like the latest MetaHuman animator, and then not have it be all weird.
Oh
Um,
sure. Yeah.
but I feel like this is the one way I found to kind of counteract the editor is just a nightmare to work with because you can just be like, okay, what do they do exactly in the UI, and
Mm-hmm.
I can just do that, and then I won't forget the steps. Um, so that's like one, at least for myself, it's been super helpful just to be like, okay, I can just look at the screencast and just see exactly all the little UI tweaks.
Yeah. And for anything that hasn't changed too much, especially in the last couple of versions of Unreal, Vikas and I have already brought it up a couple times in this podcast, but things like ChatGPT and Bard, really incredible tools that are getting better every day. So to step through an example very briefly, last week I decided that I really wanted to have tilt brush controls inside Unreal. And for anyone who doesn't know what tilt brush is, it was a project that was acquired by Google and then like open sourced for like drawing in
Yes.
VR. But forget about the drawing part. It had this really cool, intuitive way of navigating the world. You kind of squeeze your hands together to scale the world up and pull them apart to scale it down. And you grab basically the air to kind of move yourself around. And you can grab the air in two directions to rotate. And I thought, I've never seen that in Unreal. Tilt Brush was made in Unity. And I wanted to very quickly just create that. So I just started talking to ChatGPT, and it knew what tilt brush was, and it knew the basic controls. And at first it started to kind of explain, well, you'd want to use this node and this node and this node. And then I started to say things like, well, could you diagram that for me? And I'd be like, yeah, sure. And it would do like a little ASCII diagram. And then I started to challenge it and say things like, well, I'm a really visual learner, and the ASCII diagram is like vertical and it's not quite how the actual node flow is. And I said, like, do you think you could do something I could paste into Unreal? And it's like, oh, I don't feel comfortable doing that. And then I nudged it a little bit more, and I was like, well, what about Blueprint UE, which is a website where you can paste blueprint code? And it was like, oh, sure, I can do Blueprint UE, as though that's any different from pasting into the Unreal event graph. And it started to construct code that actually would paste that
Huh.
raw blueprint code into Blueprint UE. Mind you, a lot of it was broken, but once I kind of got it to like, well, like give me like the 4 nodes in the order that I really need them to make this work, to give me kind of like a skeleton of what I need to do, it would give me that. And that was actually really helpful. So I could kind of paste that in. And then I started to have some fun being like, well, forget about Blueprint UE. Like, can you just diagram this out for me? And then it starts to create
Yeah.
like these bubble charts. It uses Python to actually generate an image. And this is all, by the way, using ChatGPT-4 with the code interpreter
Yeah, yeah.
mode or module. But I couldn't believe like how quickly I was able to add in all these controls that probably would have taken me like 2 or 3 times longer if I didn't just have this companion, this rubber duck I could be like bouncing ideas off of. And every time there's a problem, every time I'm like, oh, I thought it was going to do this, it's actually doing this. And it's like, here's 3 reasons it's probably not
Yeah.
behaving the way you want. And lastly, too, here's something really great too with Code Interpreter. You can take a screenshot of your blueprint or something happening in Unreal and then say, hey, something is going wrong, here's what my code looks like. And it will interpret a screenshot of your blueprint code and say, oh, it looks like you attached this node here when it should have been attached here. Like, that's amazing to me that it can actually
yeah.
visually troubleshoot node-based graphs. And just in like the 3 days over the time that I was doing this, it felt like it got better over those 3 days. And I don't know if that was just from conversations with me or from like the knowledge it was taking in from around the world with anyone else trying to make it work with blueprints. But boy, what an incredible tool.
Yeah, I'm gonna try. I'm just gonna try some random thing here. Let's see.
Yeah.
Or if you guys have any ideas. So yeah, can you describe the steps to creating a geometry shader in Unreal 5.2 to create a curved plane? And let's see here. Okay, let's see what it says. Okay, so
Yeah, your geometry. I don't know. If you just did a vertex shader, I'm sure it would do it.
that's true. Yeah, maybe. Yeah, which I think I guess that's basically what it's doing. I think here, right? Let's see.
So geometry shading is a slightly different pipeline
Oh
inside
yeah,
of
you're right. You're right.
a
That's kind of
graphics pipeline.
pre vertex shader. Yeah, that's
Yeah,
true. Yeah,
exactly.
yeah, it's interesting. But I guess I think it correctly corrected my language and said, "Oh, let's do a vertex shader." I believe.
Hmm.
Looks
There you
like.
go.
I guess I'll
And
have to
then
look and see
my
if this is
screen's a
right.
little bit far away. What kind of code did it
You
generate?
know, this is HLSL. So if you went into
Ah,
materials and right click and did a custom node,
Yeah,
yeah.
you'd
You can
probably
paste
be
this into
able
your
you could
to.
probably
material
like
file.
make this. Yeah,
It's
yeah,
a function, so it probably I'm not sure if it would work because those custom shaders expect like your inputs and outputs to be specific names. But in theory, you could use this kind of thing.
yeah.
That's
I think
cool.
Alex's point about like I think the code interpreter is probably the way to go too, and it might even be like the way maybe the right way to sort of smooth over the editor interfaces. You just have like something like ChatGPT plus code interpreter kind of like running natively inside Unreal, and you can just
Yeah.
I
like
think
do
we're going to
stuff
see
that
that
way.
all over the place. Yeah.
Yeah,
Yeah. We'll see those plugins.
yeah,
My
Hmm.
hope is that it does actually, like we can agree on some standard of how applications should present this kind of feedback because
yeah,
right
That'd
now
be
it's
nice.
like everyone handles it a little differently. We're not at a point where like there's the global search box for all advice everywhere. Like I'm sure Google
yeah,
would love that, right? Like
yeah,
Google would love it if there was like a Google search box in every application, but that's
yeah,
not realistic. So like what kind of standards can there be? I mean, we've already spoken on this podcast extensively about uh, GitHub Copilot and
Oh yeah.
all these other
yeah,
alternatives, but GitHub Copilot I use absolutely every day. Like
yeah,
it saves
yeah.
me
It's
so
useful.
much time all the
For
time.
anyone who doesn't know what GitHub Copilot is, give a little summary of it.
Yeah. So GitHub Copilot is an extension that you can use inside of VS Code. So for
Mhm.
the non-programmers out there, VS Code is what we call an IDE, an interactive development environment, and it's a really nice one that was designed by Microsoft. And GitHub Copilot is an extension that, as you're working in code, will actively give you AI driven suggestions, and they're pretty good, if not really good, actually. And so, particularly, if you're writing a function that like you're sure like a million people have written, like
Yeah,
please write me a function that like writes a request, like a GET request that does X Y Z, blah blah blah. Like it will get that probably 99 times out of 100. And then if you're doing more complex functionality, if you just leave it some comments, for example, in a function, you try to guide it a little bit, you can get surprisingly far and save yourself a ton of time. For example, going and looking at API documentation, like all the time nowadays, instead of trying to go find documentation on every function and the parameters and everything like that, I'll just do a comment like, does XYZ with this
yeah,
plugin, and it will just pull it up. And
Yeah.
it's right most of the time. So, yeah, can't say enough about GitHub Copilot. It's a great tool. There's lots of alternatives out there as well for other IDEs, but that's the one that I've used the most.
Cool.
yeah. I
I,
think like
I believe it does pretty good suggestions for blueprint code as well,
yeah,
or like custom blueprints in C++,
Hmm.
blueprint nodes, I should say. So like if
Yeah.
you're a developer working in like any of the C++ interfaces in Unreal, the old standard used to be Visual Assist, and Visual Assist is still good for some folks. It provides a lot of suggestions specific to engine libraries and stuff like that. But GitHub Copilot does just as well, in my opinion,
yeah.
at least. Vikas, have you used it at all?
I mean, I used it. I would say I ended up using. I did use it relatively often, and then I kind of switched over to ChatGPT. It seemed to do better for a lot of code specific stuff. Like it seemed to get better sort of answers. Like I found GitHub Copilot was useful for like kind of auto completing in a lot of cases, but the the sort of like the thing where I'd have to go look up the documentation for something, it was easier to kind of just paste into ChatGPT. But I'd say like either the one that one thing that would be cool, especially for Unreal Engine and developing on the C++ side of it, is like I think none of these tools. Maybe there's this thing called Cursor. There's a company called Cursor that's starting to do this. But one thing that'd be amazing is if somebody actually embedded the whole source code of Unreal Engine, because I think right now with GitHub Copilot and with ChatGPT, it only knows like whatever it knows, like kind of the general. It's trained up on a bunch of code, and it knows like a bunch of general code, but then it only knows the local context of like what you're giving it. Um, and
Yeah.
but if you could like ask like a general question about like Unreal Engine, be like, hey, where can I, if I'm building a plugin, where can I hook into to like get the render buffer before whatever's applied or something like that. Um, I'm actually curious. Yeah, I'll have to look. I'm actually curious if anyone's actually tried that, because that would probably be super super useful, because it's
Well,
a
I
relatively
think
complex code base.
I
Yeah,
think the future is definitely being able to train these tools on your own code base.
yeah,
Sure.
And to that extent, like this would be part of it. I should also mention though that there is a new Copilot chat feature too,
oh,
and
interesting.
it's worth mentioning that these are both Microsoft. So GitHub Copilot is a Microsoft product. They're also major investors in OpenAI. They have internal access to the same models. So like GitHub Copilot, you can think of as just a specifically tuned or fine tuned model for the same or fine tuned representation of like one of the segments of something like GPT-4.
True, true.
This came out recently that GPT-4 is what's called a mixed experts model, which means that essentially they took this model GPT-4, they fine tuned it in a bunch of different domains. One of them is code. One of them might be like medical or something like that, right?
Yeah.
And essentially they have an intelligent system, or usually it's actually another model that classifies the requests into these mixed experts to get you the best possible result. So in theory, like Copilot would be a like one of those mixed expert models specifically trained on code, but the prompting is very different. And that's really the biggest difference between something like this and ChatGPT, is that ChatGPT has like a language context that shifts, whereas Copilot is gathering information from everything inside of your workspace usually.
Oh,
Uh,
really? Okay. That I didn't
yeah.
realize. That's actually pretty cool. So yeah, maybe I should try it again. Maybe they've improved it since I did it. But
Well, it's
yeah,
worth mentioning that like VS Code is not usually where you work on Unreal
yeah,
Engine, right?
true, true.
So I think it does technically support it. It's usually Visual Studio, and I'm not sure what capabilities Copilot has in Visual Studio, or if that's a
Yeah.
focus at the moment.
Actually, on a different topic that I'm curious about from you guys, um, one of the things that I was chatting with a YouTuber that's like, built a pretty awesome like virtual production pipeline, and he's built it around Blender, and one of the things that he mentioned was it was really hard for him to, you know, uh, him and I think he's got a 3 person on staff. They explored a bunch of ways to try to use Unreal instead, and they just had a big challenge in trying to match the output quality from Blender to what they were getting with Unreal. And I'm curious what you guys have found with like, obviously there's like the path tracer now, and there's like some of the historical stuff. Like, what have you found or seen, or like what difficulties have you faced if you've tried to like push the envelope with like realistic renders essentially?
First, I want to give Jacob a chance to give his usual rant about path tracing.
Nah, we can skip it. We can skip it. I don't like the path tracer. Whatever. This is a historic, canonical feature of this podcast where I go and rant on the path tracer because I feel like it's the antithesis of everything we've worked for. But that's pretty much it. That's the rant.
Yeah, I mean, it's been interesting, especially to follow someone like JS Films again, who has been doing all these really interesting tests with like 14 hours of path tracing for this 30-second Unreal Engine film and all that, and then comparing that to the 2-minute long Lumen version, and then of course the next thing would be like, well, how about the real-time version as well of Lumen. And what I'm finding is that the differences between, let's say, all three of those are getting less and less and less. In particular, right now, path tracing versus Lumen with all the settings turned up really high. Very, very hard to notice the difference, even at 4K. There's like a few things where, little reflections off eyelashes or something like that, where if you're looking super closely, you'll see that like, oh yeah, there's something else going on there with path tracing. But I think we are very quickly coming to a point where there's not going to be a lot of need for that. And it's funny too, because when people talk about things like photorealism, it's such a relative term, because it's like, well, photorealism in the sense of how physics behave in the real world, or photorealistic like someone just looks at it and it passes the sniff test. It just seems like, yeah, that looks real. Because sometimes when you're making something photorealistic, you put 3 different suns in your scene, 3 different directional lights, because that's just going to create like the right effect for what you're going for. So there's still kind of a whole artistic side to it. But kind of to your point, Vikas, like, yeah, like I am finding more and more that when I'm trying to make something look photoreal, in Unreal Engine 4.27, which I'm still spending a lot of time in, it's usually baked lighting for global illumination plus ray traced reflections. That's kind of the magic combo there, even in VR, if we've got powerful enough hardware. And then in Unreal Engine 5, whatever, Lumen and Nanite cranked up high enough, like that's kind of it. Unless it's a very tight interior scene, Lumen GI in real time, I find, is still pretty noisy. And it works okay if it's like, well, we're at a pool and there's like weird caustic stuff happening on the walls. Like you can kind of get away with the Lumen noise feeling like intentional in that respect. But yeah, it's interesting. But I think if you're going to render something out, if you're like, I'm making a short film in Unreal Engine, like you can get 99% of the way there just with the out-of-the-box Lumen Nanite stuff, and maybe cranking some of your Lumen settings up a little bit higher using CVARs, or even just going in your post-process volume.
It's worth considering like where things are headed in general with real time, right? Like Lumen and Nanite. I'm not sure why I said that so weird. Lumen and Nanite are going to be huge for a wide swath of games. It's going to be great. It's going to be very scalable for hardware, right? Like that was one of the original intentions, is that like making sure that your game can run on lower end and higher end hardware, that runs on mobile and that runs in all these other places, right? But if you look at what's going on in like the very high end, which is usually also means you have to have a really big GPU, and mostly from NVIDIA, because what they're doing with ray tracing has been very, is very relevant to this. But if you look at, for example, Cyberpunk, we talked about this a while back, where Cyberpunk released this like ray tracing overdrive mode, where they modified their engine to do like essentially similar to what you'll see in like NVIDIA's Omniverse demos, where they're doing a ton of RT acceleration to provide global illumination and reflection and near path trace results. And it's mostly driven with denoising, right? Like most real-time ray tracing, you just send a scatter of random rays into the scene, you accelerate that as much as you can, and then you denoise it. Like that's the big process here. And if you look at like what NVIDIA is still pushing on, like DLSS, that's getting better and better, right? I believe they're releasing an extension or DLC for Cyberpunk, and that was that's going to be one of the big releases for DLSS 3.5, right? But consider this: that CD Projekt Red, who are the people who make Cyberpunk, have committed to switching to Unreal, right?
They sure have.
So think to yourself, right? Like, okay, CD Projekt Red is just one company inside this ecosystem.
Yeah.
They have a visual bar that they're setting with their title now. Like, why would they move to the Unreal platform if they weren't expecting to set the same visual bar on the high end, right?
Yeah.
Sure, Nvidia is going, like, Nvidia has their own versions of the engine, and a lot of those features don't make it into the main branch for, you know, vendor neutrality, whatever.
Yeah.
But fundamentally, like, if we're looking at where the, like, where the gap is slimming, like, it's obviously happening on the high end, but it might not be happening as much in Unreal right now, but it will be. Like, there's every sign that that's going to get there, to the point where, like, Nanite is going to be critical in playing a role in the overall resolution of objects and the fidelity of the worlds, but things like neural rendering, you know, denoising, are going to be huge in terms of pushing this next bar in real time, like, realistic rendering, and that's coming very soon. Like, that's we're really only like a generation away from that,
Yeah.
in my opinion, at least.
Yeah. And I
There's a
think they're.
great explainer video. Go ahead, Vikas.
Oh, no, I was just gonna say, yeah. And I think you know, at least one of the ways we're thinking about it at Light Twist is that there's this. I think there's obviously tons and tons of advantages in just having the real time feedback. Like, you can actually, like, kind of run through and, like, you know roughly what things are going to look like, or more or less almost exactly. And I wonder if we get to a place where, at least in some cases, you kind of have, like, both a real time preview of, like, whatever you're doing, and then have the ability to kind of go back and just press a button and it sort of re-renders. Like, that's something that we're looking into, is like, and preparing for, is like, can we, do what we're doing here, but then, like, after this is after we're done recording, it just goes back and does, like, okay, cool, I've locally recorded your audio, your video, we'll just feed that back in and we'll re-render it out with, like, maybe we're not going to do 78 hours. That would cost us a lot of money, but the 21-minute render is very possible. And so
There are a lot of
this,
folks,
yeah,
yeah, who
yeah,
are looking at that.
yeah,
I just, from my perspective, believe we will get to a point sooner than people expect where, like, you don't need to worry about offline rendering, other
yeah, you just
than
do it
if you
all. Yeah,
have a specific pipeline that needs, like, if you have a pipeline that's going to utilize additional tools, or,
yeah,
you're doing things like compositing or multi-stage, rendering, like, there's still plenty of reasons you might need
yeah,
offline
yeah,
rendering. I don't think it's going away, but for use cases where you're like, oh well, we'll utilize real time to get an okay fidelity now, but
yeah,
we'll get a better output later. Like, I don't think we're going to be seeing that for much longer, to be honest.
yeah.
Yeah,
Especially,
I mean,
I guess. Oh, good, Alex.
I was going to say, even in Unreal Engine, we're starting to see more of that happening with things like MetaHuman Animator and the ML Deformer stuff, where it's like, yeah, you're getting kind of one pass at this, and then you send it up to the cloud, and then get this incredible result that is pumped through a neural network and does all this other stuff.
Yeah, there's a little bit of the MetaHuman Animator case is a really interesting one too, because it's the fidelity is so much better after that processing. But yeah, I think that you could. Yeah, it'll be interesting to see if like what that gap looks like over time. As long as the top end matches, yeah, it's like if the gap in the real time versus offline renders is, like, less and less perceptible over time. And another thing that's interesting too, like we found this from at least one of our customers, is like, they're like, look, because I was, at least for myself, I'm always, like, pretty critical about quality of various things, and I'm like, okay, what do you guys need help on? Can we, like, improve the render quality? Like, is the segmentation good enough? And they're like, no, it's actually, as long as it's, like, reliable and running, like, it's good. Like, because they're like, oh, people are watching it on phone screens anyway. It's not like they're watching it on, a huge theater, experience. And so they're like, it actually is, like, those differences are even, like, less evident at a phone screen, even though phone screens have gotten better. Like, it'd be interesting to see, like, this thing from JS Films, like, yeah, with, like, Lumen versus path tracing, and, like, if you're looking at a phone, you're probably, like, even less likely to notice that difference, right? So that
Yeah.
might be another factor that's pushing toward, like, this it sort of like reduces, in some ways it's reducing the top end of what you could perceive anyway, for at least for like virtual production kind of stuff, and so, or like rendered stuff. And so you might be like, well, there's even less reason to go offline mode, because like you don't need that quality. Like you're only going to pump, you're only like outputting at this level.
Yeah,
Yeah.
exactly.
Cool.
I think we'll get there, and it really won't be that long.
Yeah.
I had these kind of like, I had a series of predictions a few years ago that I wrote up, and I think at that point I said, okay, well, in about 5 to 10 years, like real time will fully catch up on these things. Like,
Yeah.
what I did not expect, and maybe a lot of people didn't expect, is how we would get there, right? Like a lot of people at that point would have still said, like, this is a step function with rasterization, and yeah, we'll throw in this like real time ray tracing thing, but it'll still be rasterization, you know. And now we're getting to a point where, and of course, we're in the middle of this like AI boom, so there's going to
Yeah.
be speculation. There's going to be speculation all over the place, and we can't let it, cloud our judgment, so to speak. But what is certainly true is that more and more functions seem to be saying that, oh well, maybe we'll move away from rasterization altogether, in the near term, and that would be pretty nuts.
Mhm.
Yeah.
I think people don't realize like how much of VFX and real time or everything else is built around vertices and
Yeah.
polygons and stuff that really doesn't matter in the framework of like neural rendering, or
True.
if you look at like any like AI paper on, for example, generating 3D objects from language, it'll show it as like
A neural render. Yeah.
a neural radiance field. It'll essentially be voxels, right? Like it will just be
Yeah.
logical space. Like there's just very little impetus for polygons when you're not doing rasterization.
I think,
VFX uses curves and uses these other definitions that real time doesn't, for that reason.
yeah, I wonder, that'll be an interesting, that'd be an interesting, because I've seen, I could see a future also, and maybe it's a intermediate future until the, let's say in the five-year horizon, because there are some new techniques now. If you guys have seen the whole Gaussian splatting paper that came out recently, that's like, it's kind of closer to, it's using something like neural rendering, but it's taking advantage of rasterization. So it's kind of like, hey, let's, instead of trying to train up this like effectively like a ray tracer in a neural network, which is sort of the like nerf type neural rendering. It's like, let's train up, let's actually create actual geometry in the scene that kind of looks good from all these different angles. And so, and that has a lot of advantages, partly because our pipe, like, it's like, what, we can render triangles all day in real time. Like all these different systems are built, like you said, for that. And it has some advantages in the sense that you can like, we have the ability to not just like render that, but then composite it and relight it and all this stuff. And so, yeah, I could also see another path that might happen is we might get some more explicit systems like this, where it's like you're using deep learning, but you're basically almost recovering like a geometric version of the world with like proper materials and like all that stuff. It's like, oh, like we actually got the exact BRDF on this desk now, and we got the translucency on this glass just right, and the structure of it, because like we're not using like like a SLAM sort of 3D
Yeah.
reconstruction type approach or photogrammetry. It's like this like new like, hey, what it needs to look like this from this angle, kind of thing. So
I think it's just going to
yeah,
end up being all contextual, right? Like
yeah,
the whole physically based rendering model is all designed to, it is not technically really designed around the physics of materials. I mean, some of it definitely is,
yeah,
but it's how those materials, or how light interacts with our eye and those materials, right? It's like there are many things inside of rendering that are used to compensate, not really for the physics of it, but like how human eye works and how we're used to seeing things in context, like a big one being ambient occlusion, which is not a real effect, but it's something we have to use in rendering, right? Other examples like in translucency, refraction, in PBR is most of the time used to like arbitrarily bend light because we're not tracing rays and stuff like that, right? Like, but in a contextual scenario where what that thing is, right? Like, that an ice cube is an ice cube, and that means something because you've looked through the entire human experience and database of photographs and videos of ice cubes. Like, that means a different thing, right? And so I get the feeling it's just all going to be contextual and driven by our experience. And there's going to be, we've gone down a rabbit hole here, but
no, it's an interesting one. Maybe a different maybe I'll have you guys on we're going to restart the Light Twist show at some point, so we'll have you guys on there, and we can nerd out about this topic too. No, it's awesome.
Well, I think just about there. Do you have any shout outs this week, Alex?
I wish I did. No, I didn't have a chance to go through my Twitter likes. There are some really cool people doing cool things, but we'll save them for next time.
Sounds good to me.
Awesome.
All right. Well, if we're just about wrapped up here, thanks guys for listening. A bit of a shorter episode this week, maybe I'm not sure. Usually we get about an hour 20. I think we're about an hour in. So you know what? You can have those 20 minutes back if you were planning on listening.
For the record, Jacob, I think every time you've made a prediction on the show of how long the episode's been, you've been at least 20 minutes off.
Oh, really?
In either direction.
Is that true?
Yeah.
Okay.
It's okay.
Well,
I like hearing you guess, because I think this one's about an hour. I mean, I'm going to be wrong now too, but I think we're about an hour 15, an hour 20 here.
Oh, really? Okay. Well, either way, thank you guys for listening and watching. Make sure you like, comment, subscribe, favorite, rate, whatever it is, wherever you're watching or listening. We really appreciate it, and we'll see you in the next episode.
Yeah, thanks everyone, and let us know if you'll be at Unreal Fest. We'd love to see you.
Yeah.